An arithmetic progression is a sequence of numbers that differ based on a hidden pattern. The beauty or pain, depending on whether or not you like mathematics, is seeking the pattern that ties the whole sequence together. The challenge here is to establish the general term of the sequence Tn in terms of n. We use the variable n to represent the position of the digit and the variable Tn to represent the number itself. Let's look at a simple pattern like this. The numbers shown here belong to a sequence where the first digit is 3, second digit is 7, and so on. So here's the trick. Find the difference between the digits. In this case, they all differ by 4. Since the difference is a constant in this first layer, it means the general term will have a largest power of 1. It will be a linear term of Tn equals to an to the power of 1 plus b. Now, to solve for a and b, which are both constants, I'll start with the easiest method, which is the scientific calculator. We only need the first two values, the rest are unnecessary. Observe that for the first pair, n equals 1 and Tn equals 3. The second digit is n equals to 2, corresponding with Tn equals to 7. We substitute these values into the template of Tn equals to an to the power of 1 plus b established earlier to form two equations. From here, activate your calculator's simultaneous equation solving mode and key in the two equations. Note that I'm using Wolfram Alpha's online interface here for simplicity. The outcome is Tn equals to 4n minus 1. But what if calculators are banned in your country's assessment standards? The slow and steady way would be to use simultaneous equations on pen and paper. The elimination method will work here by a simple subtraction of both equations. This allows you to solve for a value of 4. Then, substitute it back in to solve for a b value of negative 1. The last method is for those who enjoy solving equations using matrices. Form the two equations, assign a 2 by 2 matrix for the coefficients of a and b like this. Then, assign a 2 by 1 matrix for the constants 3 and 7. If you understand the rationale of multiplying an inverse matrix by the column matrix, go ahead with this method. Otherwise, skip ahead to the next example where we attempt a tougher case. Another arithmetic progression here using different numbers where we have to generalize the pattern Tn in terms of n. But watch what happens when I seek the difference between the digits. Their difference is not constant at all. So what I do now is to find the difference of the difference in a second layer. This time, a constant value is achieved. Since I needed 2 layers to achieve a constant difference, the general term has a largest power of 2, of the format Tn equals an squared plus bn plus c. Back to the solving components now, starting with the calculator. This time, we observe 3 unknowns a, b, and c to be solved, so we keep the first 3 numbers and ignore the rest. Similarly, pair up n equals 1 with Tn equals negative 1, n equals 2 with Tn equals 4, and n equals 3 with Tn equals 11 to form 3 equations. Assess your scientific calculator's simultaneous equation mode and key in the 3 equations. The calculator does all the hard work for you to solve for a equals 1, b equals 2, and c equals negative 4. The general term will now be Tn equals 1n squared plus 2n minus 4. How about simultaneous equations? Is it even possible to solve all these by hand? Actually, yes. Note that the 3 equations all have a constant of c. Apply an elimination method for the first 2 equations, and then again for the second and third equation. You now have 2 simple equations with unknowns a and b as the constant c has vanished. It's now straightforward to solve for a and b and use those values to solve for c later. The outcome is once again the same. And now matrices. The most abstract method is surprisingly quick here. This time, group your coefficients of a, b, and c in a 3 by 3 matrix. Your constants will be assigned to a 3 by 1 column matrix. Multiply your inverse square matrix by the column matrix for the values of a, b, and c. To summarize, all arithmetic sequences can be solved by finding the difference in their digits. There will be an eventual layer where the difference is constant. The number of layers at that point equals the largest power of the general term. Remove the excess values so that they don't clutter your life. Then, depending on your country's curriculum standards, use either the scientific calculator, pen and pencil, or matrices to solve for simultaneous equations. Hopefully, this hack will make you realize that cracking the code isn't so difficult after all.